East Africa. Chris.
Thank you very much. Good afternoon, everyone. It's really good to follow Caroline's introduction there on East African weather. There will be a little bit of overlap between our two talks, but I thought I wanted to start really with talking about why the Global Guidance Unit, the Met Office, got into forecasting for East Africa and why we consider it so important now and for the future, really. So I'll start off with why UK forecasters were involved. I'm going to talk through a little bit about the SWFDP phases, Severe Weather Forecasting Demonstration Project, as it's known. And that started off in South Africa, but it developed in East Africa as well, and has been sort of going for a couple of years now, helped by forecasters in the GGU. And then I'll talk a little bit about tools for forecasting severe weather. Caroline's touched on this already. And a few other forecasting tips, and then we have some time for questions at the end, or we have a break for some drinks. So the idea was a global centre for supporting East Africa. So the idea of a severe weather forecasting demonstration project, as I said, South Africa, Pretoria started this process off, and very much early on was the sort of driving force, really. And the idea was, how could national Met services provide a sort of warning service to their countries, which would be able to be used by people the same way that we have a national severe weather forecasting service in this country. So to some extent, we're building on that, but obviously, as Caroline's already highlighted, the severity of the conditions in East Africa and African countries in general is quite a bit more severe than we're used to here. So that sort of natural group of East Africa that came out of it that wanted to join were Burundi, Ethiopia, Kenya, Rwanda, Tanzania, and Uganda. And it's always been sort of traditional that Kenya was sort of like the leading part of that group. So they naturally took the lead in this sort of forecasting environment. So Nairobi was always the lead centre. Then outside of that, and how the things sort of grew in the first place, Caroline sort of touched on this. Initially, we were doing forecasts for Lake Victoria, and the very, very early part of this project started in sort of 2008, the late zeros, if you like, whereby fishermen were losing their lives on Lake Victoria. They were going out on boats. Lake Victoria, in case you don't know, is a very big lake, 250 kilometres by 180 kilometres or so. So they're going out onto the lake, getting caught in severe weather storms, and the boats are not particularly robust, getting turned over in severe storms, all that sort of thing. And a lot of fishermen were losing their lives, in the hundreds every year. And it was felt that some sort of system could be put together using the forecasters from Uganda and Tanzania and Kenya to improve that. So could that service, which initially was sending out just sort of text messages to mobile phones of the fishermen, be extended across the countries involved? And there was a real drive to do that. So the second area that got involved was Dar es Salaam itself, the capital of Tanzania, I'm sure you're aware, and they were providing specialist guidance for Lake Victoria itself and providing this service to the mobile phones of the fishermen. So inside, as well as those two countries, we also wanted regional centres. And what do we need the regional centres to do? They have sort of good model knowledge and interpretation. They have the sort of confidence and accuracy in issuing warnings, increasing the lead time. That was considered very important. Also, as we sort of talked about today, really, the idea of some sort of verification and feedback into the model, so improved observations and using those observations to verify the models that we've got. And also to improve the understanding of communicating of risk. So we're quite familiar, it's good to be in this environment at ECMWF, where risk is sort of part of the everyday culture, if you like, using ensembles to calculate risk. And that's been very important for East Africa as well. So at the end of all that sort of getting together by WMO, the World Met Organization, we received a request at the Met Office for support for this project, to help the forecasters in East Africa upskill to understand some of the model difficulties and some of the ideas behind communication of risk. So, starting off with a 4-month pilot in September 2012, phase 1, as it was called, and two people from the Met Office went to visit KMS in Nairobi and TMA in Dar es Salaam to assess what the requirements were and gain an appreciation of the working environment there, how it differed from the Met Office, if you like. And the Met Office in Exeter then started to write daily written guidance using all the models data that we had available, all the ensemble data that we had available in the region, and posted that to Huddle so that the forecasters in Africa could read it. So the regional centres were using that to inform their forecasts, and they gave us feedback on the forecasting accuracy, because obviously they've got much greater local knowledge of where severe weather is more likely in their region, and also some knowledge of what's going on the ground. And this enabled some sort of regional confidence in forecasts to improve. There's increased confidence in Exeter about what we were providing, but also the forecast in Africa had some more confidence that the ideas that they were sharing were being appreciated by the GGU as well. So there was this sort of coming together during this pilot project. So there's a little diagram there of where we were really. So we were sending our guidance out to Kenya, that was doing across the region version, and Tanzania, that were just looking at Lake Victoria for the fishermen I was talking about. Then phase 2 started February 2013, during the summer, and we had 2 forecasters each coming from KMS and TMA, from the Kenyan and Tanzanian Met Service. They came to us for a couple of weeks. They shadowed the forecasters in GGU, so they saw the way that we were producing the guidance. They looked at our facilities and processes. They met with the scientists, with Caroline and with other modelers. They observed other things at the Met Office. But the most important thing really was to formulate a sort of what was needed within this daily guidance. What we were going to provide every day that would give good information about what the severe weather was in the countries and how we could warn the countries on how to, deal with severe weather. At this stage, the Met Office generated a graphics-based guidance and established Huddle as a useful means. So we would post our forecast to Huddle, and the African forecasters would post their guidance to Huddle, and we could share information without sending huge files across the internet and bringing people's emails down. Around this time, during the late spring and early summer of 2013, we started to do a daily Skype video conference. And we had some fun with this, setting this up, as you can imagine. Not least with the Met Office firewall, which didn't seem to allow it to go through at all. But eventually we got something that worked. And we, as in GGU, used to drive that through. So we were given our assessment of it, and then the Nairobi forecaster, the Tanzanian forecaster, they would all chip in with their details, and we'd agree on a story. But not long after that, probably within about 5 or 6 weeks, we started to take a more mentoring role on the process. And if you like, we were then relegated lower down the pecking order. So it started off with Nairobi. They would lead the discussion, and they would make the final decision. And we were like a delegate into the process in the end. We would come along at the end, introduce a few ideas of where models had gone wrong, and set the scene like that. But we were sort of lower down in responsibility. So it wasn't long, as I said, about 6 weeks before Nairobi took over the conference, and their confidence grew amazingly. Not just from visiting us, but also from dealing with the daily conference and driving the conference forward. It was quite amazing to see how quickly they built up the confidence in their own forecasting and how to project that. And it wasn't long before they were sort of saying to us in GGU, I think you've got this wrong, I think we need to go down this road. So we had some interesting discussions quite quickly. But we certainly felt that we were an equal partner in this process. Okay, During the summer of 2013, there's been a lot of interaction between Rwanda, the Rwanda Met Service and the Met Office. It was felt that it would be great to bring Rwanda into this process. There's been a lot of training done by the Met Office for Rwandan forecasters, and so the idea that they could be brought into this East African SWFDP project was really important. So forecasters from Kenyan and Tanzanian Met Service visited Rwanda to have a look at what the requirements were for this admittedly much smaller country, and also to get a two-way process going. So people in Rwanda would feed back how the warnings were being received in Rwanda, and also Nairobi could feed through dangerous situations potentially that would affect Rwanda. If you don't know it, Rwanda is a very hilly country, very mountainous. So where you've got heavy rain, 100 millimeters in 24 hours, say, then that can produce a lot of flash flooding and damage in infrastructure quite quickly. In September 2013, tripartite Skype call commences. I think all that meant was that Rwanda were coming in to the whole process, so led by Kenya and Tanzania, but Rwanda were equal partners in there, giving information on the local level. And then we were into phase 3, which started really at the end of 2013, beginning of 14. Stage 1 of that was the Met Office coming back into the video conferencing when Rwanda were established. We then got Uganda and Burundi to join in with these conferences. So there was, some actual problems in effect of having too many cooks almost, where we got quite a lot of countries discussing these issues. I personally went to Nairobi, and my colleague went to Dar es Salaam to review how the developments were going there, to input into the forecasting process. And not sort of during that time, Rwandan forecasters were visiting the UK Met Office, and we could have some discussions there. Then during the stage 2 of this, I went along with a forecaster from Melina came with me from the Kenya Met Service to Burundi, and we had a look at the situation in Burundi, the particular problems there with infrastructure and internet, and my colleague went to Entebbe in Uganda as well. So we assessed the support requirements, and we wrote some reports and recommendations, which are being assessed by WMO at the moment. So although it says remainder of 2014, we still haven't got to the next stage of development. But that was a very important phase of gaining knowledge of the forecasting of East Africa and exchanging information between the two. And it's been a really useful exercise. So the video conferencing development, as I implied, so we've got Kenya leading it, Tanzania looking after Lake Victoria, Met Office GTU inputting, and Rwanda. And then the next stage was the expansion. So Uganda, Rwanda, and Burundi, if you like, were one stage down, and they were inputting in. And then the final vision, and I've just been to Rwanda to deliver some training along with Anna here from ECMWF, and the vision there is to get all of these countries involved. So there were delegates there from Ethiopia, from Uganda, from Burundi and Rwanda, and not least Edward from South Sudan, who has had a lot to cope with in that country, as I could talk to you for quite a bit about. But so a lot of support collaboration between Kenya and Tanzania, and with ourselves at GGU as well. So what does the final product look like? So these products were produced when I was there in March 2014. The green blobs that you can see on here are where 50 millimeters in 24 hours is expected. So this is the criteria that was agreed way back at the beginning of the project that would have an impact on local weather. Now, some countries argued, particularly the ones in the west, Burundi and Rwanda, argued that 25 to 30 millimeters would have an impact when you've got saturated ground already. But I think the larger countries, Kenya and Tanzania, which have a more, what do you want to call it, tropical savanna type climate, were more keen on these higher totals, and that's what's been agreed at the moment. So What tends to happen is these areas are proposed by Kenya as the lead nation, and then on the Skype conference, the discussion goes around, as to whether these areas are correct, whether they are telling the right story, and whether they should be expanded. Now, it's not just a project to do with rainfall, as you can see on here. There's also the yellow blobs with arrows are for strong winds, and obviously heavy thundery showers can produce these, and this is one of the things that was issued as a hazard on Lake Victoria. And the other thing is for coastal regions, waves greater than 1 meter. So those are the three things that go on this map. So that's a sort of summary of it. Also done at the same time and posted on the website, the Kenyan Met Service website, is a matrix here for the three things that I've described: heavy rain at the top, strong winds, and large waves, probably in ascending order really. And an X is put in the box according to what's going on. So say looking just along at Burundi, here you've got the X in the low, so most of the country is in the low risk of heavy rain, 50 millimeters in 24 hours, but the western region is particularly at risk. And you can see from that the western region here is the one that's closest to Congo, and that really is where you do get an awful lot of heavy rain throughout the seasons, really. So these forecasts are produced every day, all the way through the year, not just during the short rains and the long rains, but throughout the time. So what causes these hazards to come along to become severe? This sort of tacks on really to what Caroline's been talking about, and these are the things that we discussed with the forecasters in East Africa when we first put this stuff together. So on a seasonal level, we've got teleconnections, we've got Indian Ocean SSTs, and rainfall, what's called the Indian Ocean dipole. Heavier than normal, these can produce heavier than normal rainfall or more frequent rainfall, or produce a longer season. So this can have an impact as well, because once the ground is saturated, then any amount of heavy rain can cause landslides, can cause disruption to travel. What else could cause problems? Perhaps the concentration of rainfall events, things like ENSO and Madden-Julian oscillation, Kelvin waves. All these can concentrate the normal convective regime that Caroline talked about into a longer period of heavier precipitation, 3 or 4 days, maybe even a week. And I saw that when I was out in Nairobi. We had 4 days of really intense thunderstorms, one after the other, having had about 2 or 3 weeks with no rain right in the middle of the long rain season. Also, the influence of tropical cyclones. I'll come on to those. So MJO predictions, they come from the BOM website. They, different phases favour different amounts of rainfall. I won't go into that at the moment. It's just to illustrate that we had to point these out to the forecasters. Phase 2 to 3 favouring coastal convection. Phase 7 to 8 favouring the Western Highlands of East Africa. And this is an example of the phase 7 to 8 rainfall pattern. You can't see much on here, but on the right-hand side here, you can see where the coast of East Africa is. So this is sort of more central regions of Africa. And these intense storms were producing well over 50 millimeters in 24 hours. So this was a time, this was from the 19th of March this year, of intense precipitation. Kelvin waves, another thing that comes off the BOM website. And on here, this is for the 19th of March as well. You can see a Kelvin wave making eastward progress across the equator in Africa, coming into East Africa there. And that was something that was giving about a week's notice of a prolonged period of intense precipitation. So that enhances the normal convective regime. And when combined, perhaps with MJO phase, can cause prolonged storms, as it did in March. And in the 72 hours ending on the 11th of March, this was the pattern. Perhaps not so much across East Africa because it hadn't got going then, but across the Central African regime, particularly across DRC, that was some tremendous rainfall totals there. The purple on here is 125, 150 millimeters over those 3 days. Tropical cyclones, I said I talked about those. They have a direct impact on the coasts, particularly Tanzania, who have a lot of problem with them, from winds, from waves, from sea surge, flooding from tidal lock, etc., all of those things. You need to be a little way away from the equator to pick these things up. There are also indirect effects. If you get a strong wind blowing moisture into the African continent, then your sort of normal diurnal cycle is increased. You're adding energy into a system which has got a lot of heat in it already. So more than the usual thunderstorm development. And also anecdotally, low pressure close to the Tanzanian coast can cause a moisture westerly wind flow from the DRC across Burundi, Rwanda, and into western Tanzania. So that can really mount up the rainfall in those regions. And the forecasters are well aware of that, but it's useful to keep an eye on these things. So what tools do we have for forecasting these hazards? We have our main global models, and they are available to all the African forecasters. We also have various regional models. They have their own COSMO, which is a 7-kilometer model, which is going to come down to 4 kilometers eventually. They also have an American model, WRF, which they use again for regional modeling. And of course, the Met Office has its own Central African 4-kilometer model, which is sort of expanding from the sort of previous Lake Victoria model. So they're very useful for predicting intense rainfall, as I'll come on to. We use the bomb links for ENSO, for MJO, and for Kelvin Waves. All these are helpful for our synoptic scale forecasting. So what are the strengths and weaknesses of the 4-kilometer model? It's got high resolution orography. As Caroline said, we need to study that, but it represents local topography really well. Improves surface temperature forecasting, orographic precipitation, and it begins to resolve convective activity, which, as we know, global models can't. They just parameterize those sort of things. However, the 4-kilometer is not as good as the 1.5 kilometer, the UKV as we call it in the Met Office. So that has fully explicit convection within it, rather than parameterizing the small-scale convection. So the onset to convection in the 4 kilometer is generally too slow, and as it cannot be resolved, and results in too few cells that are too large and too intense. You often find that it's building up these cells too quickly. Land-lake breezes, day-night differences, some of those are not well handled in the global model, but in the 4 kilometer they're quite good. Particularly over Lake Victoria due to the convergence over the lake. And the general pattern of convective cells can look realistic, but cell location, number and size, often we need to look at that a bit more closely and perhaps look at some of our verification schemes to see where we do well. So satellite imagery and observations are very useful still for confirming developments. A lot of the data we use, 24-hour rain gauge totals, usually we get those via TRMM data, tropical rainfall measuring data from satellites, very useful to verify forecasts. Lightning detection, that's a new thing that is being put forward to African forecasters. When we started this project, we never had ATD, and that's been very useful. And the daily Skype conferences are quite useful for ironing out differences between the centres. Before, we used to have a lot of differences. Now, because we can get to discuss them, we can iron those things out. So as an example of TRMM data from the 3rd of November, so that's very useful for getting rainfall over these huge countries for which we've got very little amounts of data, which we sort of talked about before. And just to emphasize, those were the SRUD data, those were the data that came onto the GTS for the 3rd of November. So reasonable coverage across Lake Victoria and parts of Kenya, but down here in Tanzania, very few observations at all. And this is a country that's sort of, well, it's about 1,000 kilometers from here up to Lake Victoria. So over 600 miles or so, we've got 1 or 2 stations reporting. ATDNet is available now through UMetcast, and it will be available on the BCP Africa LAM website. And this has been very useful for forecasters. This is a concept at this stage. This actually was taken from storms developing across the UK. In fact, EGBB there is Birmingham Airport. But it shows where the lightning strikes are in relation to the storms, so it would help African forecasters in showing where the heaviest storms are. And also, it's also been used for nowcasting, for getting the position of the storm. So if we know where a storm was 10 minutes ago, then we can use that to do nowcasting. Other forecasting tips. Local knowledge is very important. There's a very exciting initiative in Kenya where they're putting forecasters in their regions to help them communicate forecasts into the region. I think that's a very exciting project, and it will help feed back heavy rain and flooding. Often the beginning and the end of a season can bring the most severe conditions. Certainly when I was in Nairobi, that was the case right at the beginning of the long rain season. We need to remember backbuilding storms, wind shear on tetograms, and convergence lines to confirm our suspicions. And I'll finish with this slide. As we're at ECMWF, the forecast index is very much used by African forecasters. You're pleased I said that, aren't you? That's all I've got to do.